Hello, settle in, get comfortable, and allow your mind to prepare for a journey. Today, we are going to talk about silence, the infinite, velvety silence of space where stars are born and die. We are used to thinking that when we peer into that darkness, we are searching for the answer to whether or not we are alone in the universe. But what if we are asking the wrong question? What if the greatest secret space hides isn't about who else lives within it, but about what else exists alongside it? Imagine for a moment one of our most powerful telescopes, designed to gaze into the universe's past, accidentally, for just a fraction of a second, looked sideways and photographed something no one was meant to see, a fragment of a different reality. Tonight's sleep lecture is the story of one such photograph, an image that could change everything. Prepare to hear how a standard scientific procedure led to a discovery capable of shattering the very foundations of our established reality. Before we dive into the story itself, let's set the necessary stage. We need to understand how the eyes of humanity work when gazing into the abyss. We are talking about the great observatories and space telescopes. Names like Hubble and James Webb are familiar to everyone. Their primary task is to collect light from objects so distant that their emissions have traveled toward us for millions, sometimes billions of years. Essentially, they are time machines. They show us what galaxies looked like in their youth. One of the most famous observation methods is the deep field survey. Astronomers choose a tiny, seemingly empty, absolutely dark patch of sky. Then they point the telescope at it for hundreds of hours, meticulously gathering every single photon, every particle of light. The result is that the image, where there was previously only blackness, reveals thousands of galaxies, thousands of new worlds. This is routine, painstaking work. The data arrives on Earth, is processed by complex algorithms, and then analyzed by scientists. And within this massive stream of data, among trillions of pixels, astronomers search for confirmation of their theories. But sometimes, very rarely, they find something that no textbook prepared them for. Our story begins at the Kronos Observatory, a facility perched atop a remote, isolated peak deep within the Andes Mountains. Here, in the thin, crisp air, far removed from the light pollution of civilization, a team of astrophysicists was dedicated to a project named Omega Deep Field. The goal was ambitious yet standard for modern science: to create the most detailed map ever produced of one of the oldest sections of the observable universe. Months turned into a monotonous routine. The massive telescope faithfully focused on its target coordinates, collecting precious, ancient photons. Data streamed onto the servers, accumulating gigabytes of raw information that would take years to fully analyze. It was meditative, almost mechanical work. No one expected surprises. The universe, for all its grandeur, adheres strictly to the laws of physics, laws that the scientists at Kronos knew intimately. On one of those utterly unremarkable nights, beneath a flawlessly clear, crystalline sky, the overnight shift was being handled by Dr. Aris Thorne. He was a young, yet exceptionally talented specialist in astronomical data processing. His job was to monitor equipment calibration and oversee the initial processing of incoming images. For Thorne, this was perhaps the 100th, maybe even the 200th such rotation. The control room was defined by the monotonous glow of the monitors, the low hum of the cooling systems, and the endless stream of code scrolling across the screens. He took a sip of his now cold coffee and listlessly scrolled through the latest data array collected over the previous few hours of observation. And that was when, in the corner of one of the thousands of image frames, his attention caught something strange. It was barely perceptible, just a handful of pixels that were behaving incorrectly. They didn't resemble a star, they didn't look like a distant galaxy. In fact, they didn't match anything in the known catalogue of celestial objects. It was an anomaly. What exactly constitutes an anomaly in an astronomical image? While a layperson might hear that word and think of something mystical, for a scientist it's just business as usual. Space is riddled with interference. A satellite zooming past might leave a bright streak. A high-energy particle, what we call a cosmic ray, can slam into the telescope's sensor matrix, producing a bright spot or an erratic pattern. Even the hardware itself can malfunction, resulting in hot or dead pixels. Then there are the gravitational fields of massive objects like galaxy clusters, which bend the light from more distant sources, creating optical illusions known as gravitational lenses. All of these are standard artifacts that astronomers are trained to recognize and filter out. In fact, entire software packages exist purely for scrubbing images clean of this kind of digital noise. What Aris Thorne observed at first seemed to fall squarely into one of these common categories. It was a tiny, barely discernible structure that resembled a delicate, glowing spiderweb. It was too geometrically precise to be random noise, yet far too faint to be a star. Aris's immediate assumption was that it was the trace of a cosmic ray that had struck the detector at an extremely unusual angle. He initiated the standard verification protocol. The software compared the anomalous frame against the preceding and succeeding exposures. If it were a cosmic ray strike, it would only appear on that single shot before vanishing. But the structure remained. It was static. This was weird. Very weird. He ran diagnostics on the sensor itself. All systems reported nominal function. No glitches, no overheating, no deviations from the baseline. The anomaly wasn't housed within the telescope. It was out there, in the cosmos. The following morning, Aris presented his findings to the project leader, Dr. Evelyn Reed. She was a middle-aged woman known for her keen, penetrating gaze, and she had a reputation as one of the most meticulous, perhaps pedantic, astrophysicists alive. Having devoted her life to studying the cosmos, she had zero tolerance for dilettantism or rushed assumptions. Evelyn glanced at the image on Aris's screen, frowned deeply, and without uttering a single word, began her independent verification. She opened a console and typed in commands with lightning speed. She checked the telescope logs for that specific night, reviewed the data from space weather sensors, and ran several complex diagnostics to rule out hardware malfunctions. Her verdict was swift and absolute. That's just a residual image from a bright star that passed through the field of view during calibration weeks ago, she stated, without looking up. The sensor matrix often retains ghost images of exceptionally luminous objects. Run it through the deep cleansing filter and move on. It was, admittedly, the most logical and simplest explanation. The phenomenon of ghosting or persistence was a well-documented technical issue. But Aris had already discounted that possibility. He had pulled every calibration image from the last 6 months. Not a single bright star had crossed that specific patch of the sky. He started to protest, but Dr. Reed had already returned to her desk, a clear indication that the conversation was finished. For her, the case was closed. Science had no patience for sensationalism built on shaky data. There was a strict protocol, and there were standard procedures. The Thorne anomaly fit perfectly into the category of statistical noise, something to be purged and disregarded so they could move forward. But Aris couldn't dismiss it. Something about that thin, luminous structure nagged at him. It was too elegant. It suggested an underlying logic that random interference simply could not mimic. Days bled into weeks, but Aris Thorne couldn't shake the image of that strange anomaly. Officially, he was focused on his ongoing projects, yet every spare moment, every evening, he found himself drawn back to the data. He was starting to feel obsessed, and he knew his reputation was on the line. If this turned out to be weeks wasted chasing a mundane artifact he'd simply overlooked, a rookie mistake, his career in serious science would be over. But his intuition, that elusive sixth sense that separates a good scientist from a truly great one, screamed at him that he was on the cusp of something monumental. He decided to try a different approach. If it wasn't noise and it wasn't an object within our own galaxy, perhaps it originated far beyond it. He began analyzing the light emanating from the mysterious structure. Through spectroscopy, the process of breaking light into its component colors, just like a prism, he could determine the object's chemical composition, temperature, velocity, and distance. This is the absolute bedrock of astrophysics. When Aris saw the initial results of the spectral analysis, he couldn't believe his eyes. The data was nonsensical. The spectrum didn't match any known star type, nebula, or galaxy. Worse yet, it contained absorption and emission lines that, according to the known laws of atomic physics, simply shouldn't be possible. It was like trying to read a book written in a language using an entirely alien alphabet and grammar. He double-checked the calculations obsessively, searching for a bug in his software. But the error wasn't there. The light from the object behaved as though it had traveled from a place governed by entirely different fundamental constants, different laws of physics. Redshift is one of the foundational tools we use to measure cosmic distances. It works because the universe is expanding. The farther away a galaxy is, the faster it moves away from us. As the light travels to us, it gets stretched out, shifting towards the red, or longer wavelength end of the spectrum. By measuring this shift, we can accurately calculate the distance. It's similar to the Doppler effect we hear with an ambulance siren. The pitch is higher as it approaches and lower as it moves away. The same principle applies to light. Aris attempted to calculate the redshift for his anomaly, and once again he was faced with the impossible. The program returned constantly shifting values, sometimes positive, indicating redshift, sometimes negative, indicating blue shift, and sometimes zero. The light from the object was simultaneously receding, approaching, and standing still. It was physical nonsense. This was the exact moment Aris's initial unease spiraled into genuine, chilling dread. He sat alone, deep in the night, in the silence of the observatory, staring at numbers that screamed one thing. The universe he had dedicated his life to studying might not work the way he thought it did. He decided to take a major risk. To get a clearer image of the structure, he needed to combine data collected over several nights of observation. This process, known as image stacking, demands enormous computational power. Aris secretly rerouted the resources of the main observatory server, disguising the processing job as a routine calibration procedure. He waited for hours while the computer meticulously stacked hundreds of images, filtering out the noise and amplifying the useful signal. When the final image finally materialized on screen, he held his breath. The luminous web came into sharp focus. It was instantly clear that this wasn't a chaotic structure at all. It was composed of distinct nodes connected by fine filaments. It looked exactly like a neural network, or perhaps the map of a city glowing brightly in the dark. A city the size of a galaxy. With his hands shaking, Aris printed the image and carried it straight into Dr. Reed's office. He didn't say a word, simply laying the sheet on her desk. Evelyn looked up from her papers, giving the image a quick, cursory glance, then a second, much longer look. Her face, usually so inscrutable, shifted. Slowly, she picked up the print and brought it closer to the light. For several silent minutes, she studied the complex glowing structure before finally looking up at Aris. The condescension was gone from her eyes. It had been replaced by shock, and perhaps fear. "What is this?" she whispered. Aris laid out everything for her. The meaningless spectrum, the impossible redshift, the results of the data integration. He spoke quickly, rambling slightly, terrified that she would dismiss him again. But Evelyn listened intently, never interrupting. When he finished, she remained silent for a long time, staring at the photograph. "Do you understand what this means if you're right?" she finally asked. Aris nodded. He understood. If this wasn't an object in their universe, there could only be one explanation. It was an object from another one. A window. A puncture in the fabric of reality through which they had seen something that existed beyond the confines of their world. It was a hypothesis so monstrous, so unbelievable, that vocalizing it felt like madness, but they simply had no other explanation that aligned with all the collected data. All known physics stated that such an object could not exist. Therefore, it existed where a different physics was at play. That day, Project Omega Deep Field was unofficially suspended. The entire operational capacity of the Kronos Observatory was secretly rerouted to study a single, tiny patch of sky. The next few weeks turned into a frantic, high-stakes brainstorming session. Eris and Evelyn operated under the strictest secrecy, confiding only in a handful of their most trusted colleagues. They became a dedicated ghost-hunting team, desperately trying to prove the existence of something they themselves barely believed in. They checked the equipment repeatedly. They called in engineers for a full diagnostic on the telescope, always inventing plausible excuses for the inspection. The instruments, however, were in perfect working order. Next, they pointed a separate, less powerful telescope located on the other side of the planet at the exact same patch of sky. And it, too, registered a weak, barely perceptible anomaly. This was crucial confirmation. The object was real. It wasn't the result of a single instrument error. Now they needed to understand its nature. Where could it have come from? The other universe hypothesis sounded like pure science fiction. Science demanded stricter definitions. That's when one of the theoretical physicists they had brought in, an elderly professor named Dr. Liam Fine, uttered the word that changed everything: brain. In string theory, one of the most advanced and complex fields of modern physics, our three-dimensional world is posited as just one of many brains, states, or membranes, floating within a multi-dimensional space-time called hyperspace. Imagine a stack of paper. Each sheet represents a separate universe governed by its own laws. They could be infinitely close to one another in this higher dimension, yet we, as creatures with only three-dimensional perception, cannot see or interact with them. We are confined to our own sheet of paper. However, the theory predicted that under specific conditions, such as brain collisions or massive gravitational disturbances, a leakage might occur. Gravity, or even light, from one brain universe could briefly manifest in another. Dr. Fane's hypothesis was both elegant and terrifying. It explained every anomaly Eris and Evelyn had encountered. The nonsensical spectrum? Of course. The light originated from a universe governed by different physical constants, where atoms radiated at entirely different frequencies. The impossible redshift? Naturally, the object wasn't actually moving away from us within our own spatial dimensions. It resided in a different dimension entirely, rendering our conventional understanding of distance irrelevant. The geometrically perfect mesh-like structure? Perhaps it was an intelligent megastructure, or merely a natural formation conforming to the laws of that other universe. They weren't looking at the object itself, but at its shadow cast upon the wall of our reality. It was akin to two-dimensional beings confined to a flat plane, observing the shadow of a three-dimensional object passing above them. They wouldn't grasp its true shape or be able to explain its nature, but they would certainly know they had encountered something that transcended the limits of their reality. The Kronos team had stumbled upon a shadow from a higher dimension. The sheer scale of this idea was so overwhelming that the scientists were paralyzed for days. They wandered the observatory corridors, exchanging silent, wide-eyed glances, trying to comprehend the sheer magnitude of what they might have uncovered. All human knowledge, history, religion, and philosophy had been built on the single axiom, that our universe was the sum total of existence. And now, printed on a small sheet of paper, they held the irrefutable proof that this was not the case. Humanity was not merely one of countless civilizations in the cosmos. We were one of countless universes in the multiverse. The realization brought with it a crushing sense of responsibility. What were they supposed to do with this knowledge? Publish it? Just imagine the headlines. Scientists prove existence of parallel worlds. This wouldn't just trigger a scientific revolution, it would unleash chaos. The religious, philosophical, and social foundations upon which society was built could collapse overnight. What is the value of human life when there is an infinite number of other universes populated by an infinite number of other people? What are our laws and morality worth if, just around the corner, in a different dimension, entirely different rules apply? As the lead researcher, Evelyn Reed made a difficult executive decision. The information could not leave their small group, at least not yet. They needed to gather more data, secure undeniable proof, before they could even consider sharing the discovery with the rest of the world. Their work continued under even stricter secrecy. They classified the project under the code name Phantom. Every day they focused the telescope on the anomaly, attempting to register any changes. And changes there were. The structure wasn't entirely static. It shimmered almost imperceptibly, pulsing as if it were breathing. Sometimes parts of it brightened, while others faded. The scientists theorized that the window between worlds was inherently unstable. They were only catching random glimpses, brief moments when the veil between realities grew thin. They tried to find a pattern in these pulsations, attempting to link them to observable events in our universe, gamma-ray bursts, gravitational waves. But there was no correlation whatsoever. The existence of Phantom followed its own, incomprehensible rhythms. It was frustrating, yet utterly captivating. Aris Thorne was driven by the radical idea that the spectre's light wasn't just an image, it was data. If this source was a highly advanced civilization, perhaps they were deliberately transmitting information. He began subjecting the light pulsations to rigorous cryptanalysis, searching for deliberate patterns, some underlying code. Using the most powerful pattern recognition algorithms available, he analyzed the slightest fluctuations in brightness and color. Most of his efforts proved futile. The chaotic flicker remained stubbornly chaotic. But one day, after months of continuous monitoring, one of his programs flagged a result. It detected a complex repeating fractal pattern embedded in the signal. Fractals are mathematical structures that repeat themselves at different scales, found everywhere in nature, from snowflakes and coastlines to our own circulatory system. But the fractal Aris discovered was impossibly intricate. It contained a staggering amount of data. This was clearly not a natural phenomenon, it was the product of intelligence. It was as if someone on the other side had deliberately used a fractal code to encode a message. This was the breakthrough. They didn't just have an image of another world, they had potential contact. But what was the message? Deciphering it was utterly impossible. It required understanding the fundamental mathematics and physics of the universe from which the code originated. It was a lock for which humanity would never possess the key. Yet the mere existence of the pattern changed everything. It meant the spectre wasn't just a natural anomaly, it was an artifact, or at the very least, it bore the undeniable hallmarks of intelligent design. Out there, beyond the veil, something, some entity existed. And this entity was capable of manipulating the very fabric of reality on a level humanity couldn't begin to comprehend. The discovery of the informational pattern was a game changer. They now possessed something far more significant than a mere anomaly. This wasn't merely evidence of different physics, it pointed toward the potential existence of another intelligence. Evelyn Reed realized they could no longer afford to keep this discovery contained within their small team. The risks of internal silence were simply too immense. What if another observatory happened upon the same data and released it prematurely, completely misunderstanding its profound implications? They had to act, and they had to be careful. Using encrypted channels, she contacted the leadership of the international scientific consortium that funded the Kronos Observatory. She offered no specifics, only suggesting the detection of a phenomenon fundamentally inexplicable by the standard model of physics, and requested an immediate high-level summit. 2 weeks later, the meeting convened in Geneva under absolute secrecy. Attendance was strictly limited. Heads of the major space agencies, 2 Nobel laureates in physics, and key representatives from government bodies overseeing science and national security. Evelyn and Aris presented their evidence. They displayed images, spectral analysis charts, redshift calculations, and, crucially, the complex fractal pattern embedded within the signal. A heavy, profound silence fell over the room. These were scientists and officials accustomed to dealing only with predictable, measurable phenomena, and yet they stared at the screen with a mixture of utter bewilderment and deep awe. They peppered the presenters with questions, desperately trying to find a flaw in the computations, searching for any terrestrial alternative. But the Kronos team had meticulously vetted and rejected every possible natural explanation. By the conclusion of the presentation, not a single skeptic remained. Everyone in that room understood they were bearing witness to a monumental historic moment. For the first time, humanity had tangible, quantifiable evidence that we were not alone. Yet this solitude was shattered in a way nobody had anticipated, not by the dramatic arrival of an alien vessel, but by a quiet, faint light emanating from a different dimension. The decision reached at that meeting was unanimous. The information had to be classified. This wasn't driven by malice or some global conspiracy, but purely by a profound sense of responsibility. Humanity simply wasn't ready. Releasing this knowledge into the public domain unprepared could trigger an unpredictable chain reaction, mass panic, religious conflicts, the collapse of the global economy. Before they could speak to the world, they first needed to understand exactly what they were facing. What was this new reality? What were its intentions, if any? Was this window stable? Could anything pass through it? The questions far outnumbered the answers. A secret international project was immediately initiated, codenamed Phantom, sharing the anomalies designation. Its sole purpose was the comprehensive study of the phenomenon. The project recruited the best minds on the planet: physicists, mathematicians, cryptographers, linguists, even philosophers and anthropologists. Every major telescope in the world, both ground-based and orbital, was secretly redirected to observe this mysterious patch of sky. Officially, the Omega Deep Field project was abandoned due to insurmountable technical equipment failures. Data gathered by the Kronos Observatory was seized and placed in an ultra-secure archive. Aris Thorne and Evelyn Reed, the original discoverers, became the lead researchers for Project Phantom. Their lives were changed forever. They were no longer merely astronomers. They had become the custodians of the greatest secret in human history. The years passed. Project Phantom continued its work in absolute silence, completely invisible to the outside world. The scientists had, however, made measurable progress. They learned to predict the brief moments when the window became perceptibly more transparent. Using these fleeting opportunities, they managed to create a more detailed map of the visible structure, which proved to be truly colossal, spanning a region of space comparable to several galaxy clusters. Crucially, they confirmed that the structure was not indigenous to our universe, as it showed no participation in its ongoing expansion. It was as if it had been painted onto a static backdrop, the canvas against which the drama of our own cosmos unfolded. But the central, baffling question remained: what exactly was it, and who, or what intelligence, was responsible for the persistent informational signal? The cryptographers struggled relentlessly with the fractal code, but their efforts were fruitless. It was akin to deciphering the entire meaning of War and Peace, armed with only a single page, written in an utterly unknown language. Linguists and anthropologists constructed hundreds of models for a potential other intelligence, attempting to anticipate its logic. Yet all of it amounted to little more than guesswork, reading tea leaves. A consciousness evolved in a universe governed by different laws of physics might be so profoundly alien to our own that meaningful contact would be inherently impossible. This was the deepest, most unsettling form of isolation imaginable: to stand before a window into another world, to clearly perceive its light, yet know you could never cry out, never even begin to understand the entity standing on the other side of the glass. Aris Thorne, now well into his 40s, often found his mind drifting back to that night in the observatory, the night that irrevocably split his life into before and after. He had made the greatest discovery in history, yet he couldn't share it. He knew the truth about the cosmos, but was forced to live a lie. The secret weighed upon him like a crushing burden. Sometimes he wished he had simply dismissed the data as an equipment malfunction and moved on. But then he would look again at the last images of the spectre, at its cold, unearthly luminescence, and he knew he couldn't have done anything else. In science, there is no turning back. Knowledge, once gained, is impossible to unlearn. He often pondered what lay on the other side. Was it a civilization so ancient and powerful that it had mastered interdimensional travel? Or merely a natural phenomenon, a trick of light and shadow playing out across the boundary of two realities? Or perhaps the most terrifying thought of all, did they know about us? Were we not observing them, but rather were they observing us through that tiny, accidental window? That realization was the most chilling of all. Humanity, with all its petty wars, ambitions, and frantic existence, might simply be an object of study for something immeasurably older and wiser. A laboratory mouse, utterly unaware of the scientist watching it through the glass of its enclosure. This metaphor haunted his sleep. As the new head of the Ghost Project, Evelyn Reed carried an even heavier burden of responsibility. She wasn't just coordinating the scientific research, she was constantly locked in negotiations with powerful government officials. She watched as the realization of what the project meant transformed people. For some, it was a terrifying threat. The unknown invariably breeds fear. They demanded the creation of a weapon capable of closing the dimensional gateway, or at least one that could protect them from potential invasion. Others, conversely, saw the Ghost Project as a source of limitless opportunity. If we could slip from one universe to the next, it meant the transfer of energy and information was possible. This promised solutions to all of humanity's major crises, the energy shortage, incurable diseases, perhaps even mortality itself. Evelyn had to navigate the treacherous space between these two extremes, absolute paranoia and a naive faith in miracles. She insisted that their sole mandate was study, to understand, not to utilize, to observe, not to interfere. Any reckless action, any attempt to tap on the window could trigger catastrophic, unforeseeable consequences. They were dealing with forces far beyond human comprehension, and the best strategy was therefore maximum caution. They were like the first humans who encountered fire. It could warm and protect, or it could burn everything to ash. And before trying to harness it, they needed to observe it carefully, and for a very long time from a safe distance. One day, while sifting through a fresh batch of data, one of the project's younger analysts spotted something new. Against the familiar architecture of the Ghost, a minuscule detail emerged that had never been present before. It was a small, perfectly round, dark pinprick, a shadow. It looked as if something had momentarily eclipsed the light emanating from that other world. Initially, they dismissed it as yet another data artifact, but verification confirmed the spot was real, it was present, and it was moving slowly, excruciatingly slowly. This marked the first dynamic event they had ever recorded in years of observation. Everything prior had been either static or erratically pulsing. This, however, was clearly directed motion. The scientists of Project Ghost froze, captivated. Computers immediately began calculating the object's trajectory. It was moving deliberately, traveling from one node of the glowing network to the next. Rough estimates placed its size as comparable to our entire solar system. What was it? A vessel? A planet? Some immense living entity navigating its native environment? There were no immediate answers, only a feeling of pure, primal astonishment. They were watching the life of another world unfold. They were witnesses to an event taking place in a different reality. The dark spot continued its migration for several months before it finally came to rest near one of the network's brightest nodes and vanished. It simply dissolved as if its presence had been erased entirely. No one knew what this meant. But the event solidified the conviction among the researchers. The ghost wasn't merely a beautiful pattern etched across the sky. It was a living, breathing, and fundamentally changing place. The story of the dark spot was immediately filed as another classified chapter within the archives of Project Spectre. To the world at large, the universe remained unchanged. Humanity carried on with its daily routines, completely oblivious that the very foundations of their shared reality had already begun to fracture. Meanwhile, scientists outside the project continued to devise elaborate theories regarding dark matter and dark energy, attempting to explain gravitational anomalies in the movement of distant galaxies. They didn't know that some of these strange fluctuations might be caused by a gravitational echo emanating from a neighboring brane universe. Philosophers debated the meaning of existence, never suspecting that the very definition of life could be exponentially vaster and more diverse than their wildest imaginings allowed. Yet, high in the mountains, within the silent dome of an observatory, and in dozens of other secure facilities across the globe, a small, isolated group of people kept their vigil. They were staring into the void. They were humanity's first emissaries to the multiverse, silent observers standing on the threshold of infinity. Theirs was the most crucial, yet most solitary work in existence. They guarded a knowledge that might one day save humanity. Or perhaps destroy it. They couldn't be sure. They simply watched and waited, waiting for Project Spectre to signal them again, for another sliver of light to bleed through the veil of reality, carrying within it the secrets of another world. One of the most daunting philosophical hurdles the project participants faced was the problem of uniqueness itself. If the multiverse is real, it suggests the existence of an infinite number of copies of every single one of us. Somewhere in another universe you made a different choice, and your life followed a totally different path. Somewhere you became a hero, somewhere a villain. Somewhere you were never even born. This idea, known as the many worlds interpretation of quantum mechanics, undermined the very foundations of identity and free will. If every possible outcome is realized in parallel worlds, what is the meaning of the choices we make right here, right now? Aris Thorne spent a long time contemplating this. He finally came to his own conclusion. Even if there were an infinite number of his copies, the only life he truly possessed was this one. The only reality he could genuinely impact was his own. The knowledge of other worlds doesn't devalue ours. On the contrary, it makes it even more precious, because it is ours and the responsibility for it rests solely with us. This realization helped him cope with the burden of the secret. He wasn't merely the keeper of a secret, he was the protector of his world, a protector against knowledge his world was not yet ready for. Perhaps this was his true mission. Not to open the door to another reality, but to ensure it remained locked until humanity was ready to peek inside without losing its collective mind. But what about the photograph itself? That single first image captured at the Kronos Observatory, the catalyst for everything that followed. It was housed deep within a special cryogenic archive, shielded from all external interference. It had transformed into something like a sacred artifact, the defining relic of a new, secret faith whose only acolytes were the scientists of Project Phantom. Sometimes, in moments of profound doubt or crushing fatigue, Evelyn Reed would descend into that archive just to look at it. Staring back from that grainy, nearly featureless black and white image was the captured essence of all the cosmos's power and profound mystery, a single, small photograph that simultaneously held the greatest triumph of the human mind and its crushing total defeat when facing infinity. It served as a stark reminder of our world's fragility, of the needle-thin line separating knowledge from madness, order from chaos. And it reminded her that the universe's most profound mystery wasn't hidden in distant galaxies or unreachable dimensions. The ultimate enigma was us. Our capacity to wonder, to seek, to question, and to embrace the answers no matter how terrifying or incredible they proved to be. This photograph wasn't merely an image of another reality. It was a mirror reflecting humanity's true image for the very first time, a tiny, curious child standing on the shoreline of a boundless cosmic ocean. And that child had only just started its journey. And so, our lecture draws to a close. The story you've just heard, of course, is entirely fictional. As of today, we have no concrete evidence that other universes exist, But crucially, that doesn't mean they don't. In fact, the most cutting-edge theories in modern physics, like string theory and inflation theory, suggest that the multiverse isn't just science fiction. Instead, they propose it is a logical consequence of the very laws that govern our reality. Perhaps right now, at this very moment, some astronomer, much like our fictional Eris Thorne, is staring intently at a monitor, seeing something that simply doesn't fit into the known picture of the cosmos. Something that is the very first sign, a whisper from beyond the veil. Science is a constant journey into the uncharted. Each breakthrough simply cracks open the door to even grander mysteries. The most thrilling idea of all is that the greatest discoveries, the ones capable of utterly reshaping our perception of reality, are still ahead of us. They are waiting, hidden in the deepest reaches of the cosmos, etched into a theoretical physicist's blackboard, or maybe concealed in a random flicker on a telescope image. They are waiting for us to be ready to observe them. And when that day arrives, humanity will be forced to re-examine the most fundamental questions. Who are we? Where did we come from? And where are we going? But alongside these questions will be a new one, the most profound of all. Are we truly alone in the multiverse? So we have journeyed from a simple, accidental anomaly on a screen to a hypothesis that fundamentally reshapes our understanding of reality itself. We have seen how a scientific quest, driven by the curiosity of a single individual, can lead to a discovery powerful enough to shake the very foundations of civilization. The story of Project Phantom is one of immense mystery and immense responsibility. It reminds us that the universe is immeasurably vast and far more complex than we can possibly imagine. And perhaps the most incredible wonders are not hidden among distant stars, but are literally just a step away from us, concealed behind the invisible veil of another dimension. What we currently perceive as the entirety of existence may only be a single page in the infinite book of creation. Thank you for spending this time with me, traveling to the very edge of our understanding. I hope this story has given you plenty of food for thought, and yet allows you a peaceful, deep night's sleep. Don't forget to subscribe to the channel so you don't miss our next journeys into the world of science and mysteries. If you enjoyed this account, please hit the like button. And now for the main question I want to pose to you. If you were in Dr. Reed's position and made such a monumental discovery, what would you do? Would you tell the world, risking utter chaos? Or would you preserve the greatest secret in history for the sake of human stability? Share your thoughts in the comments below. Good night.